Hi and welcome to the second part of 3D Pythagoras, where we're trying to find the height on a pyramid. So inside this pyramid we first of all need to identify the two triangles that we're going to use. The first one we're going to need is we need to work out the length of A to C that goes along here. Okay, my right angle is just there. So if I was to draw that out like we did last time, the triangle I've got to work out the length of A to C is a length of 8 and a length of 10. So using our basic Pythagoras, we're going to do the square root of 8 squared plus 10 squared, which is going to give me the root of 164. I could simplify that, I could turn it into a decimal, but I'm going to leave it like that for now. We're now going to do the second triangle. So the second triangle is the purple one that I've just drawn. If I was to draw that out, I already know what the hypotenuse is going to be. It's 20. And funnily enough, I've just worked out what the base is going to be. So the base is half of this length. The root 164 is the whole way from A to C. I only want half of it. So this length is going to come all the way down here, and I'm going to divide it by 2. That is the length that would fit in there. Now I've done this, I can do the proper Pythagoras. So I can do the square root of 20 squared minus the square root of 164 divided by 2 squared. You can type that in exactly as it is on the calculator, or you could work out this section and take it off of here. It will make no difference either way. If I do that, I end up with the square root of 359, and if I turn that into a decimal, 18.95 to 2 decimal places. Give that a go, see how you get on, check you've got that answer. Here's one for you to have a go at then, following the method that I have just given you. So first thing, you need to work out your length A to C. So my length A to C goes across here. So my triangle should look like that. Complete your Pythagoras on that part then. So the square root of 10 squared plus 10 squared, which is the square root of 200. Hopefully that's what you've got. Now I'm going to think about my second triangle. So I have my upright triangle here. Label it up with the sides that you've just got. So did you get that the hypotenuse is 12, and this length down here is the square root of 200 divided by 2. That value, remember, comes all the way down there. Then have a go at your Pythagoras. So the square root of 12 squared minus the square root of 200 over 2 squared. If you've typed that into the calculator correctly, you should have the square root of 94, which is 9.70 centimetres to 2 decimal places. Some of you have contacted me regarding this question that has appeared on your work. So this question is asking you to find out the length of the dotted line. If you look very carefully, you've actually got right angled triangles here. Okay, they've noted that they're right angles in the corner. So the first one we're going to work out is we need to work out, in order to find this length, I'm going to want this one and this one. So using this triangle that's on the side, okay, I'm going to do 7.7 by 7.7, and that is going to tell me this red line going along here. So if I work that one out, that is going to be 7.7 squared plus 7.7 squared, and I want to square root that. Have a go at working that out now for me. And that's going to give you an answer of 10.89 to 2 decimal places. If you can use your answer button on the calculator, then do it. The second bit I need to work out is the length I'm about to highlight in purple for you, which is this length along here. Now, hopefully this is a 7.7 by 7.7 by 7.7. So we've got another triangle that is 7.7 by 7.7 again. And this is, remember, to work out the purple line along here. I'm going to want half of that in a second. And that is again going to be 7.7 squared plus 7.7 squared, which again is 10.89 centimetres. Now that we've done that, this shape up here, I'm actually only interested in the red line, the purple line and the dotted line. So I have actually got a third triangle this time to do some Pythagoras on. That third triangle looks like this. So the red line is this one here. And we've just worked that out to be 10.89. The baseline is the purple line, but it's only half of it. If you look at the diagram, that actually cuts the shape into 2 pieces. So you actually only want to have half the line just here. So I want 10.89 divided by 2. So that's going to give me 5.44. So to work out the height, which is the dotted line, which is this one here, I'm going to do Pythagoras with a subtraction. So 10.89 squared minus 5.44 squared, obviously that's all under the square root, and that is going to give me a final answer of 9.43. It doesn't matter if you have different numbers on yours, but it will allow you to follow the method through, hopefully, and work through those questions. Hope this has been helpful. Good luck.